All right, so more about exponentials. This is our day 2 on this. Hopefully you're recognizing this is the kind of the main form. It's right up there with y equals mx plus b, or y minus y sub 1 equals m times x minus x sub 1. These are some forms we've used of different equations. You remember that? So here's a new one now. So now you should be able to recognize whenever you see one of these that that first thing, that a, that's the starting value, also called the initial value, and that is called the base. And it's what tells you if it's growth or decay. All right? Moving on. This right here tells me a starting value. What is it? 3. So there might have been 3 horses in the field or whatever. And this means that the number is going to what? Grow or decay? Grow. That's standing for growth. And this x in the exponent is telling me it's what kind of thing? It's an exponential. All right. This one, still growth or is it decay? So growth, can you tell me what percent growth? 20% growth. What if this had been a 0.8? It would not be 80% shrinkage, it would be 20%. All right, good. Now, here's an important thought, and some of you smarter kids are going to be able to follow this. The rest of you can just look like you're understanding. The starting value is the same as the y-intercept, because on the graph it looks like this. And the y-intercept is where x is 0, right? So if I put in x is 0, it should tell me the starting value. So if I put in x is 0 there, anything to the 0 power is 1, and 1 times 3 is 3. That'll tell you the starting value. So if you're not smart enough to figure it out by the fact it's the number in the front, you can say the the y-intercept is where x is 0, put in a 0 here, and then figure out what the starting value is when that turns into a 1. All right, it's just another way to think of the starting value. This one's been shifted. It's the same kind of thing. It's got a starting value of 3, so I'm going to start at 3. And then it goes like this, and how steep it is depends on this. Remember, the bigger the number is there, the steeper it is. And the last thing is this whole thing gets shifted where? Up 2. So I grab it and I go 2 spots. Okay. This is not exponential growth. What's this? It's a rainbow. It's an exponential decay is correct. So they're all going down. So I'm not going to look at it until it's the start value, and then it goes down from there. All right, moving on. Exponential growth, it's important to me that you understand that this is intricately related to this, and that's the log. The log goes with exponential growth. These guys go together because they're called somethings. Inverses. They're inverses. All right, and they're inverses because they're a reflection across this line right here, which is the line y equals x. So that brings in a third function. So there's 3 major functions of the 12 biggies you're supposed to know for precalc that all kind of go together here. You get that? Log and exponential, and this is called identity. All right. So what happens when we do this? Well, I know the start value. What was it? 2. Did it grow or decay? Decayed. And that means it decayed 63%. True or false? False. It must be 37. Okay, 30% drop. And then the graph would look like, well, if it's decay, it starts here at what? 2, and it goes down, right? How steep it goes down depends on how much decay factor there is. All right, moving on. This, I am digressing to remind you that you have to be able to do that without a calculator. You can't just type it in because they won't have a calculator. So you'll be able to handle a few weird exponent things. Here's some weird exponent things. 5 to the 0, what is it? 1. Anything to 0 power is 1. 5 to the second is nice and easy. It's what? 25. But how about now? 1 over 25. Very good. So a negative up there flips it. How about if it's a fraction like 1/2? What does that mean? Square root. What the heck is the square root of 5? You'd write square root of 5 because you don't know what it is other than that. Okay, how about if it's 25? Then you'd know the answer. 5. How about if it's a combo of all 3 things? Negative 3 over 2. Well, and you break it into 3 parts. You go make it smaller before you make it bigger. So you go 1/2 and 3 and negative 1. Because when you multiply these all together, you get this, and it breaks it into 3 easily managed steps. Square root of that is what? 5 cubed is 125. Flip it. 1 over 125. Excellent. All right, so I think now, with that little reminder, you can figure this one out. Do it on your paper right now. Just you and your paper and your pencil. Unless you're German, in which case you'll just sit there. Yes, this is what they call review. It could have been. 9 is a really common number to use because it has a square root, and yet it's got, you can also cube the square root fairly easily. Because if you go to numbers that are too big, like 64 or something, then when you take the cube or the square root of it, you have 8, and then you try to cube that, 8 cubed, I don't even know what that is. So. All right, so hopefully you knew that it was 9 to the 1/2 to the 3rd to the -1, and that would be 3. 3 cubed is 27 to the flip it is 1 over 27. So 2 times 1/27 is 2/27. Raise your hand if you followed that. You understand that. Okay, good. Moving on. One more. Same idea. Different flavor. Try it. If you come up with a nice, easy number, then you probably did it right. The loneliest number. Very nice. All right. 27 to the 1/3 to the 2nd to the -1. Always make it smaller before you make it bigger. So this is, now a lot of people get stumped right there. What is the cube root of 27? 3, because 3 times 3 is 9 times 3 is 27. So it's 3. 3 squared is 9, and then you flip it as 1/9. And 9 times 1/9 is 1, which is the loneliest number. Very good. Okay. Moving on. Oop, where did that? How about this? That's just a V shape that's been shifted and flipped and stuff. Remember that? Same idea here. If you know what the parent is, you can just think of this as the parent function that's been flipped a couple times. But what is 5 to the x? Hopefully you can just, in your head, picture something like this, and then how steep that is depends on what base it is, so that's probably good enough right there. Now what's that flip in there doing? Is that a left-right or an up-down? It's a left-right. And then the other one's an up-down, so it doesn't really matter. You just have to do both flips. Okay, so if I do the first flip, it would go something like this. And then the second flip would go something like that. So my final answer would be this one. All right. Moving on. This guy. It's a function. And you should know what the parent one looks like. And if you don't know what e to the x is, you've already forgotten that graph I keep drawing. It looks like this, and then this is e to the x. And what's this guy again? Log. Okay. So back to, oopie. I'm getting lost. There. It should just look like this. How steep is it? Well, what is e? Do you remember what e is? 2.7. So it's really like 2.7 to the x, and that's a lot like 3 to the x. Anyway, so this guy is going like this, basically. And then we do that to it. Well, it's flipped, and it's 3 times wider. True or false? False. It's not 3 times wider. It's 1/3 as wide. Good. It's always opposite of what you'd think when it's on the inside. And it's like that's on the inside. All right. How about this one? Is it moved? Is it right or left? Right. And then down. Right 5, down 4. Moving on. Okay. This problem I talked you through yesterday, but then I realized that there's another way that you need to know that could also do this problem that's really important. There's kind of like a theme developing here. At the very beginning of the year, we gave you 2 points, and you should be able to figure out the straight line that goes through them. That's that y minus y sub 1 equals m times x minus x sub 1. Remember that? Now we're giving you, oh, and the next thing we did was a parabola where we gave you 2 points. We gave you this point and some other point, and you had to figure out the equation for the line that goes through them. Well, now we're giving you 2 points again, a starting value and one other point, and we're asking you to give the equation for that. So all of these things always boil down to an equation that you start with, like, to see if you remember this one. Well, how do I end that one? Plus k, actually. You were close. It's a letter. All right, so that one is the quadratic one. And if you had 2 points, you'd stick the vertex there, and you'd stick the other point there. Do you remember this? All right, so now we need one more of these general formulas. Have you seen it today? Yes, you have. Y equals a b to the x. Write it down. I'm going to give you 2 points. One of the 2 points I'm going to give you, take a guess. What do you think it'll be? Kind of like 0. It's the starting value, which is also the y-intercept. It'll be the starting value, and you're going to put it right there, right? That's the point. That's why I kept saying over and over again, that's the starting value. Because we're going to give you a starting value, you put it right there for A. And then we're going to give you another point, like 5 comma 7. And logically, you're going to put it in for the x and the y. So if I gave you, I started at 3, and my other point it goes through is 5 comma 7. Now I just have to solve it for b, and I'd be done. That's where you put the stuff. The point goes here, and the starting value goes here. All right, so let's do one. Let's say that we had a starting value of 0 comma, and notice it'll always be 0 comma because it's the y-intercept. It's where x is 0. 0 comma 7. So that's my start. And then my next point it goes through is at, let's say, go over 1 and up 9. 1 comma 9 is the other point. All right, now this involves some funky algebra to solve, and this is the hardest part, no doubt. This is the hardest thing, and this will probably be your R3 level kind of question. But you may not get it the first time, but you'll get it the second or the third. All right, so you start with this. Y equals a b to the x. And I know the start value, it's 7. Some people will struggle with this, but you just have to know that the 7 goes here. Done. If you really want to make it complicated, you can put the x is 0 right here, and then b to the 0 will turn into what? 1, and then you'll just have your 7 in the spot it's supposed to be in the first place. So it's really just simplest to say, start, put a 7 there. How about the other point? X is 1, y is what? 9. So 9 equals 7 times b to the 1, which is the same as just b, and then I divide it, and it's 9/7 equals b. I'm almost done. So how do you finish then? Well, the point is to get an equation. That's not an equation, that's an answer. The equation should look like this. Y equals, and then a b to the x. But we know a 7 times b to the x. There we go. That's our equation. It would have a start value here, and it would go through that other point. If my life depended on it, and my math teacher was an evil tyrant, and he was going to kill me. This sounds like some sort of a Saw movie, except to be more like Pie instead of Saw. The math teacher like locks you in the room. If you don't get it right, he kills, like chops off a body part or something. All right. Am I actually recording this? Okay, anyway. So if you put in this point, 1 comma 9, if I put in a 1 and a 9, it would have to work. Otherwise, I did it wrong. So what's my point? On the test, when your grade does depend on it, maybe it'd be smart to take the answer you think is right and double check it. So then, if I multiply this out, 9 should equal 7 times 9/7 to the 1. Well, that's the same as 9/7. And do you see how these 7s will cancel? And it actually works? Okay, so you can be sure you did it right. It'd be smart to do that. All right, so back to this problem I started with right here. I said, you know, there's another way I could have showed you to do this. Yesterday I showed you one way. This is the way, if I said starting point, do you get that that's the starting point? 0 comma whatever, that's the start. That's this spot where it touches the y-intercept, okay? So that's my starting value, so I know I start with y equals, I'd put the 0 in, but it's too much of a waste of time. I'm just going to go right to the 3/2. And then this is b to the x. And now I can put in any other point. Any of the other points on the list. Some of them are easier than others to use What do you think would be the nicest thing to put in for x? X is 1 is really nice. Okay, if x, I put in this one right here, because then if x is 1, you see how b to the 1 is just b? And I'm pretty much almost done solving it. And the other is 3/4. So I'd have 3/4 equals 3 over 2 b to the 1. And b to the 1 is just b. Some people get stuck solving this. How do you get the b alone? I like the idea of multiply by 2/3 on both sides. You can clear the fraction if you want. If you want to multiply both sides by 4, that's fairly smart. Cancels that. 3 equals 4 times 3 is 12 divided by 2 is 6b. And then my 3/6 is b. What did I just do? I just figured out b. So now I can get my final answer. Y equals 3/2 times b, which I just figured out. 3/6 is the same as 1/2 to the x. And that's the right answer. Now, you may feel like, well, I like the other way we did it yesterday better. It's fine. But you're not always going to have a list like this. A lot of times, you're going to have a picture like this. This is just like what you're going to have in your test and on your homework. It'll have a point here like 0, 2. And then it'll have some other point here like, 5, 9. And then you're supposed to figure out the equation for it. Try it right now. The starting value is 2, so I'm just going to put a 2 in there. I'm trying to do this one step at a time. I'm going to stick in 5, 9. 9 equals, see, I'm stuck. How do I get rid of that? It's not that bad. Wouldn't you agree that if I was b to the first, that I would be done? Because b to the first is b. You know what to do? You're exactly right. If you put this to the 1/5 power and this to the 1/5 power, that times that makes 1. So it's b equals 9/2 to the 1/5. That is a really awful looking answer, but it is totally right. So now I got to finish. Can you finish strong here? Y equals, what's the start value? 2. And then I'm supposed to put b, which is 9/2 to the 1/5. And the whole thing goes to the power of x. And so my final answer is y equals 2. And it's 9/2 to the, and you just have to multiply those. 5 over x is one way to say it. Or 1/5 x is the same thing. All right, and you don't have to be a ninja at this yet. Just by Friday.
Next Friday.
Right, not by tomorrow Friday, by next Friday. Yeah. Next Friday. Yes. X over 5. Did I flip that by accident? I did. Sorry, I was a little dyslexic there. Sorry. Thank you for stopping me. Some kids at home are probably going, what the heck just happened? Yes, I meant x over 5, and then I wrote the other. Sorry. I wasn't testing you, but I do make mistakes. All right. If I were in this class, I'd be the kid that usually got 3 out of the 4 R3s right. And I'd be happy because I'd be getting my A, but, some of you guys are get 4 out of the 4 R3s and then even pull off the R4. I have a few R4s people in here from last semester. I'm hoping I got a few more new ones, some of my new faces. Any of my new faces ever pulled off a 4 before?
Once.
Ah, all right, cool. Good. All right. Your homework is surprisingly just like what we just did there, except it's got one more little thing that I want to talk about, and that's inequalities. if I graphed this, I know what it looks like. It's really steep, right? And I graph that, it's the same idea except not as steep. So it goes more like that. Where is this one, the red one, smaller than the other one? Do you get it's right in that zone right there, where the red one is smaller than the black one? Just graph them both. Wherever the one is lower than the other, then it's less than it. And where is that zone? It's from negative infinity up until 0. Correct. You're correct. Did I use a graphing calculator to do that? No, I used the power of my brain because I know what this looks like compared to what this looks like. And I didn't have to be perfect about how steep they were. I just knew the one was steeper than the other one. All right. All right, so there we go. And your homework for today is write this down on a separate sheet of paper. Page 286, problems 13, 14, 21 through 24. And then I shortened it up in my classes to 31 through 40 because the last 4 questions were kind of gratuitous violence. So I don't think you need that many problems in one night. So I try to be realistic with you that I'm giving you an assignment that I know you can do. And I'll even cut them down sometimes like I just did. And it'll mean, on the other hand, that I actually expect it to be done tomorrow. Barring, you know, your little dog fell in a well and you had to save it or whatever. Other than that, it better be done. Okay. In this scenario, we have 8 minutes left approximately in class. And I would think the best way to use that is I do 2 of your homework problems with you because then you don't have to go get books. By the time you go get the book and you open it and you put it back, it's going to be no time left. So I'll just do a couple of the first problems with you, and then the rest you can do at home, and I'll give you a couple minutes at the end to chat. So here we go, number 13. You have a question first, or?
What do we do if we don't have a book?
If you don't have a book, that's a good question. They are online. Let me show you. It's on Schoology. Go under, see where it says Files and Links? One of the options is Files and Links, and I just uploaded it last night. It's right here, Chapter 3. You click on it, it opens, it looks exactly like a textbook.
Okay.
It's in color even. So what if you don't want to have to carry your book around? Then don't. Leave it here at school. If you have a good internet connection, go to Schoology. Just remember it's under Files and Links. Okay? That's also where you find the YouTube videos like this video I'm recording right now. It'll be here. Under Files and Links, it's under the YouTube channel. You just click that, and the latest ones are on the top. And I always label them with the date and the class, so it'll say precalc, and it'll say the date that it was done. So if you miss one from a couple days ago, you can go back and watch it. All right, so now back to the first couple problems of the homework. Number 13 is the first problem of the homework. And it says it's got 2 points. A starting point, 0, 3. And it's got another point. And it's at 2, 6. Gee, I just did a bunch of problems like that, so it should be fairly easy to process how to do that one. You start with y equals a b to the x, and I stick in the start value right here, so that's 3. And the other point is 2, 6. I put it there and there. You just solve it for b. Now this does get a little weird at the end, so I'm going to keep doing it with you here. So we got 6 equals 3b to the second. I'm going to divide by 3 on both sides, and I get 2 equals b to the second. And right here, if you choose to use the square root sign, it'll mess up your life. Instead, use to the 1/2 power. It's way easier, because otherwise your answer will look really weird. So b to square root is the same as to the 1/2 power, right? So b is just b to the 1 now. And 2 to the 1/2, even though it seems like it's complicated, when you stick it into the formula, it'll make total sense. Y equals the start value of 3 times b, which is 2 to the 1/2 to the x. And now if you can just make one last little leap, you'll have y equals 3 times 2 to the power of what? x over 2. Thank you for making sure I'm not dyslexic on that one. Okay. There's another one just like that, and it's number 14. I'm going to give you the points, and you can choose to do that, or if you need to rest your brain, you may. Number 14, starting value is 0, 2. And its other point is a little weird looking, but you just go with it, and it'll work. The other point is 1, 2 over e. When this one's all done, trust me on this, you'll have this as your answer. But a lot of kids won't know what to do with that, but somebody smart can probably help us right now. What's another way to write that? E to the negative 1 is correct. That's the same thing as that, and that's a way better way to write it. So just remember that at some point that'll be in your answer. Okay, I think that's enough for today.